Follow my finger with your eyes only.
So you're up next. Come back with me.
We have something in the neighborhood of 100,000 people in Canada who have multiple sclerosis. And the significance of that is it's actually about the highest incidence in the world. Trying to figure out why, where, and how are, of course, very important questions for us. So the imaging gives us a beautiful insight into the brain because, of course, it's non-invasive. So we can follow the lesions even prior to their development, and we can see what happens over time. It's very important to have collaborators in this kind of initiative. So we need clinicians who are aware of the disease symptoms and the progression. We need imaging physicists who can develop tools that can actually look at the biology. And we need to talk to each other to understand how the biology actually affects the imaging. We have all of those collaborators here in London, and we're actually able to make a significant contribution because of that.
One of the projects we're doing, which is collaborating with Dr. Ravi Menon, is looking at cognitive changes over a 7-year period, so what's changing in these patients. So we don't understand how MS is caused, and we understand even less about what causes cognitive impairment in MS. So we're really hoping having a 7T MRI study that's longitudinal will give us a really good insight into how cognition is changed in MS.
MS is one of the most difficult scientific problems I can think of. It takes, the central nervous system, which is certainly one of the most complex organs and tissues in the body, and then it combines it with the immune system, which is equally complex. And then you put the two together and how they interact, it's a very difficult problem. So in our collaborations with Dr. Menon, we're now trying to take our models that we have, put them inside the very impressive magnets at Robarts Research Institute to get the kind of information out that we can't currently get access to.
My hope is that using the techniques that we have developed and maybe trying to get them into lower field scanners, that we will be able to diagnose MS at the very first instance, which will allow us to start various therapies at the beginning. And the great benefit of that is, if you start early enough, you tend to arrest the progression of the disease. So while it's not a cure, it will stop an enormous amount of disability.